All right, welcome back. So in this video, we're going to be going through 3 examples on how to solve quadratics by taking their square roots. But first, let's establish these 4 very general steps on how to solve quadratics by using square roots. So when we see these situations where we can solve by square roots, typically it's going to be of the form ax squared plus c is going to be equal to 0 in some regard. It may look different because they might have the c on the opposite side, or they may have a constant term on the left-hand side or on the right-hand side, and there may not be an a value. It could just be 1, but this is our general setting when we're going to want to solve by square roots. The first step we want to do is to isolate that quadratic term. The quadratic term is going to be this ax squared. We want to isolate that. The second step is to divide by the coefficient of the quadratic term. Again, that's only if a is not 1. If a is 1, we don't need to divide because then x squared, or the variable squared, is going to be isolated. Step 3 is you're going to take the square root of both sides. A key step here is that we use plus and minus. We want to use that plus and minus. And the fourth step is we're going to simplify as best as possible. So let's go through 3 examples. It says solve by square roots and find the x-intercepts. A main reason, and not the only reason, but a main reason why we want to solve these quadratics is we want to see what the values of the x-intercepts are, what the value of the roots are. So we're going to be going through this process now. Notice I have 2x squared minus 32 is equal to 0. So I wanted to first isolate that quadratic term. I'm going to add 32 to both sides. So we now get 2x squared is equal to 32. I need to isolate that x squared, so I have to divide both sides by 2. So now we get x squared is equal to 16. So now we need to take the square root of both sides. So we're going to get that x all by itself now, because taking the square root of something squared cancels each other out. So now we have technically plus or minus the square root of 16. And we know the square root of 16 is going to be 4. So we get plus or minus 4. Some teachers are going to say to write it out, and if you do write it out, you would say x is equal to 4, x is equal to negative 4. All right? So that's a very arbitrary example. Let's go on to something a little bit more complicated. So again, it says solve by square roots and find the x-intercepts. We want to follow those same general steps. So the first thing we want to do is isolate that quadratic term. So I need to subtract 3 on both sides. That cancels. We're now at 5y squared is equal to 13. That I want that y squared all by itself, so I need to divide both sides by 5. So now we get that y squared is equal to 13 over 5. Some people are going to say use it in a decimal. I like fractions. They are exact. Decimals, sometimes we need to round, but I feel if we have the understanding of how to work within fractions, we're going to have a much better understanding on how to solve by square roots. And now we need to take the square root of both sides. Going to cancel and cancel. So now we're going to get, I'm going to write it over here on the left. I'm going to get that y is equal to plus or minus now the square root. Actually, let's do it in a different color. Sorry. Oh no. Y is equal to plus or minus the square root of 13 over 5. Now we need to simplify this fraction. We can't have a radical in the denominator. So I have to now simplify the square root of 13 over 5. So I'm just going to rewrite it. So we get the square root of 13 over the square root of 5. I can't do 13 divided by 5, so I have to now multiply by root 5 over root 5. When I do that, I get 13 times 5, and what is that? It's 65. Over now the square root of 25, but we know the square root of 25 is 5. And we can't simplify the square root of 65 over 5. Although they both have a factor of 5, the 65 is underneath the radical, and we can't operate with numbers underneath the radical with numbers outside of a radical. And we can't simplify the square root of 65 at all, so this is actually going to be our final answer. But let's just make it all neat. Let's bring it together. So we get that y is equal to plus or minus the square root of 65 over 5. Awesome job. Keep it up. Keep it up. One more example. So this is going to be an example that you sometimes see, not always as an answer, but there is a possible situation where you're going to get the answer we are going to talk about here. So I want to follow the same steps. I want to isolate that quadratic term. You just subtract 17 on both sides. So we get 3n squared is now equal to negative 13. Now, a lot of students are going to stop here. They're going to say, oh, I have a negative constant term over on the right-hand side. That can't happen. Do not stop until you take the square root, because sometimes you're going to have a negative a value. So you don't want to stop until you get by taking the square root. So now 1 divide both sides by that a value. So we get n squared is equal to negative 13 over 3. I can't simplify that at all. And now we take the square root, and then we're going to see, hey, n is equal to plus or minus the square root of negative 13 over 3. For our purposes, this is going to yield a no solution. And that's because we cannot have a negative in the radical. So if you notice, we have a negative right here. And we can't have a negative in the radical. That's why we get a no solution. This is going to be a situation where we get a no solution as our answer because we can't have a negative underneath our radical. When you get it to algebra 2, you can talk about complex numbers, and you can have a negative underneath the radical, but for algebra 1 purposes, we're not talking complex or imaginary. We are going to yield this as a no solution. And what that really means is, since it's a no solution, this means it has no x-intercepts. Has no x-intercept. Means it's not going to cross over that x-axis. All right, great job, everyone. If you have any questions, please feel free to reach out. Keep up the great work. Mucho proud of you.